Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to part 6 to our Pixel Platformer series. This series was made possible by the people who support me by purchasing my Godot course. If you're interested in that, it's on sale right now. There'll be a link in the comment section and the description. In this video, we're going to create a walking enemy that walks back and forth in our world. And the first thing we need to do is set up a test scenario where we can test to make sure that our code is going to work properly in different scenarios. So the two scenarios that we need to test are 1, when the enemy has walls, and 2, when the enemy has edges, because we want our enemy to turn around on the edges. You could make it so that the enemy just falls down when it comes to an edge. That's up to you. But I wanted to do one that detects an edge and turns around if there's an edge there and doesn't just walk off cliffs. So we're actually going to, the other thing that we're going to do real quick before we get started with the enemy is we're going to take this background color and we're going to change it so that in game we see a different color than this. And we can just come into our world node. I'm going to attach a script to it. And inside of the ready function of our world node, I'm going to place visual server.set default clear color. And we're going to set this to color.aqua. There's a whole bunch of colors you can choose from. So you can select whatever color you want. This will just make our background really bright, to be honest. Maybe we don't want to do aqua. Blue light. Here's kind of a light blue. We could try this and see how this looks. Yeah, I mean, that looks good. We'll leave it at light blue for now. So that's just going to set your background color when the game is running. It's a quick way to get something that doesn't look so awful, because that one color looked really awful. But we can keep this gray color inside of the editor, because I found that changing... You can set the default clear color inside of the project settings. I don't remember exactly inside of editor, maybe 2D. I don't remember exactly where it is, but you can set it inside of the editor. And but I found that it makes it really bright and kind of distracting. I much prefer the gray color inside of the editor, and then just set it in a script like this for when we run the game. Now let's create our walking enemy. We're going to create a new scene for this. We're going to use a kinematic body. Call this walking enemy. And we're going to attach an animated sprite. And on this animated sprite, we're going to create some new frames. Click in here. We'll make this a walking animation. We'll rename it. We'll click here on frames, add frames from sprite sheet, choose our character sprite sheet. We'll do 9 and 3. Now, I've done this before, right? And we're going to hold Control and then scroll to zoom in. And we're going to pick this little guy with the spike on his head, and we'll just pick these first 2 frames here. Now we're going to move up the animated sprite node to where his little feet or wheels or whatever are right on this line. We'll save our walking enemy. Now we're going to add a collision shape. And I'm just going to do a normal shape node. So we're adding that to our enemy scene here. I'm going to add a new rectangle shape. And I've got grid snap off, but pixel snap is on. If you come into here, see pixel snap is on. And we'll go here and here. So we're going to kind of leave his outline out of this collision, and we'll leave the spike out too for now. We'll save this, and we'll attach a script to our little walking enemy. And we're going to give him a direction. So direction equals vector2.right. Then we'll do a velocity. Although we don't really have to have a velocity here. We're going to do it anyways. And then we're going to do a physics process. In this physics process, we're going to move our character. So we'll say velocity equals direction times 25. And then we'll say move and slide velocity. Okay? Now we can put our little character, our little enemy, over here where he's supposed to go. We'll grab walking enemy, drag him and drop him into here. Want to line it up right with the ground so that his collision shape is right on the ground. We can run the game and see that he does walk over, although we should move our character over so that we can see right away. We'll stick our character here. And there we go. We can see he walks until he reaches a wall and then he can't turn around. So now we need to determine whether we need to find a way to detect if there is a wall next to us. Now, one solution we could use is by using Raycasts. And so what I'm going to do here is not what we're going to keep, okay? This is just me showing something, so you don't have to follow along at this time. So I'm going to add a Raycast node. I'm going to cast over 2 pixels to the right. So imagine you have a raycast like this, and this raycast is on, and it can detect whether there's a wall to the right of our character. Okay? So I'm just doing this for the sake of example. You don't have to add your raycast. Now he would walk along, and right when the raycast detected the wall, which would be here, we could make him turn around and start walking the other way. Right? So that's not a bad way to do this. But something to keep in mind with it is that if your character walks up to an edge like this, the raycast can't detect it, right? Or if you're walking up to an edge like here, the raycast also can't detect it because it's just a single cast coming out from this point. So it can't detect these edges. Your little walking guy would get stuck. So that's the problem with using a raycast. And it's, like I said, it's not a bad solution and it's something you should consider, but you should also consider the scenarios where it could have issues. Now you might say, well, just move your raycast up. Whoops. Move your raycast up, have 2 of them, you know, and you're right, but then it wouldn't detect like smaller shapes that could fit through this gap. And again, maybe your game doesn't have smaller shapes that could fit through that gap, so it doesn't matter. And raycasting would work great for you. And we're actually going to use raycasting for detecting the ledges, but for detecting our wall, we have a much simpler solution. If you'll remember, we can pass in an up direction into our move and slide. So we can pass in vector 2.up. And this allows us to use some functions like isOnWall. So we can make a variable up here at the start of our physics process. We'll call it var found wall. We'll set this equal to isOnWall. Now we have access to this great function, which can just check to see if we're touching a wall. And it uses this vector to determine whether or not something is a wall. And then we can say if found wall direction times equals -1. And what this does is it just flips our direction, right? Direction is 1. This is what our direction currently is. I'm going to make this a comment. If we multiply this by -1, which is what we're doing here, that will give us -1, 0. Because 0 stays the same, and 1 changes into -1. So we're flipping the direction from right to left. But if our direction is left, it will flip it back to right again. That's the benefit of using this. And now we can just see that if he finds a wall, he immediately turns around. Now we count as a wall too, and this could cause some issues, although it doesn't really cause issues. We can also stand on his head, which feels kind of weird. But yeah, we can just use simple isOnWall check. Now we need to check for ledges, and this is going to be trickier. We're going to use Raycast for this. So I'm going to create a single Raycast. We're going to call this ledge check. Or edge check, I guess. Edge check. I don't know, I like ledge check more. It's up to you. We're going to move this Raycast and we're going to stick it right over here. Just 1 pixel up. And we're going to have it cast down 4 pixels, 2 pixels. I don't think it actually matters. 2 pixels should be fine. Now make sure you enable it. If your Raycast is gray, it means it's not enabled, so make sure you enable it. And just as a heads up, Raycasts by default are only set to collide with bodies, so they won't check for areas, although you can toggle the area check. And also they're set by default to exclude their parent, so it won't detect this collision with the parent, with the enemy. Okay, now we need to get access to our Raycast. So we're going to say on ready var velocity. No, velocity. Ledge check is equal to ledge check, and we'll get access to that. Then we can create another variable here inside of the physics process to help our code be readable. Var found ledge equals not ledge check dot is colliding. Now that's a little bit weird to say not ledge check is colliding, but if it is colliding, that means there's not a ledge there, right? That means we found the ground. So we want to do not, and that means we found open space. So if we found a ledge, we're going to check for not colliding. Then our found wall here can just be or found ledge. And we can come up here and come into our world. We can move us over here and move our little enemy right over here to the new test scenario. And boop, turns around right at the ledge. He's going to break here. Well, he doesn't break. He just doesn't turn around until we go clear off the ledge, right? Now, how can we figure out what's going on here? Well, it's useful to know that inside of Godot, there is a debug option called visible collision shapes. Maybe I've already talked about it in this series. It could be hard to remember. And we can use that to see what's going on here. And you can see our Raycast is only on the right side. And so therefore, it doesn't check until it's clear over here. Now, we could add 2 Raycasts and then just check them both to see if either one of them has found a gap. That's not a bad solution, actually. So we could name this one ledge check right. It's so funny that I've just decided to run with this solution. I had a different solution planned, but I like this one more. Ledge check left. I just duplicated it, renamed it. Now we need to get access to both of them. Ledge check right. So rename this ledge check right. And we're going to do for ledge check left on ready var ledge check left is equal to ledge check left. Now we've got both of them. And for found ledge, we need to do ledge check right and not, wait, no, this is an or, because if either of them have found a gap, it doesn't have to be both of them. In fact, we don't want to find a gap with both of them. So we want to make sure this is an or not ledge check right dot is colliding, or left dot is colliding. See how this looks. See if this works. Walks to the, oh, we forgot to reposition the left one. Let's come to ledge check left, click on it here, and then drag it over to the other side. And now you can see that our enemy walks back and forth. Now there's a problem here. And the problem is that we can actually push our enemy off this ledge if we move slowly here. Push it right off. And then it's going to freak out there. Now this has to do with how Godot calculates inertia and stuff like that. And it can get rather complicated / outside the scope of this series to go into that and how you could handle the character pushing the enemy off the ledge. We're going to take a much simpler approach, which is going to be, we're going to make the character and the enemy so they don't collide with each other. And then we're going to use hitboxes for the damaging collisions. And we kind of sort of did that with our spikes, and we're going to take some of that. And this will probably be in the next video. We're going to take some of that and move it over so that we're using hitboxes. But for now, we're just going to completely remove collisions with the enemies. And let me show you how we're going to do that. We're actually now going to get into the other half of collisions. If you come up into your project settings and you come into 2D physics, you can see all of these 2D physics layers, and there's 32 of them. And we're going to name the first two. The first one, we're going to name it world. And that's going to be for our world collisions, like our tile set, our ground, anything that's like part of the world. Then we're going to have another layer called characters. And this will be for our player and our enemies and stuff like that. So we've created 2 named layers under our 2D physics section. And now, when we go into our character, for example, let's open up our player, and we click on the kinematic body 2D. If we come over to collisions here on the right, there's 2 collisions actually. So make sure you get the one that's under collision object 2D. You'll see layer and mask. Now the layer is the layer that this collision object is on, and the mask is the layer that this collision object looks to for collisions. Okay? So the layer is the one you're on, and the mask is the one you're looking to. So for our player, we don't want it on the world layer, we want it on the characters layer. But we want it to look to the world layer. So now it is on the characters layer, and the mask, or the layer that we're looking to, is the world. So now our player can collide with the world, but won't actually collide with other players because it's not looking for them. We'd have to do this to have it collide with other players. We're going to do the same thing with a walking enemy. We're going to check collision. We'll move it to characters and let it detect the world. Now our raycasts are already set up to detect the world, right? So they're already set up for that. So that already works for us. Now if we come into our world, we're going to want to go into our tile map here. Go into the scene. So open up our tile map scene. Click on tile map. And over here on the right, it also has collision. And we're going to make it, we're going to put it on the world layer, but it doesn't need to look to any other layers. It can just exist there. And the player and the enemy can look to it. So we'll just set it on this layer and have no masks. There's no masks here for it. And we'll come into our spikes. And we'll have our spikes look to, we'll have them exist on the world layer and look to the characters layer because we want them to detect collisions with characters to try and hurt them. Now our player can just go through our enemy, right? So we can't push it off the ledge, but our player can still collide with the ground. Now if you find that this isn't the case, then there's probably an issue with how you set up your collision masks and layers, and it can get confusing, I understand. It was really hard for me to pick up on when I first started learning Godot, so don't feel bad if you're having a hard time with it. It's not just you. And but yeah, remember the layer is the collision layer that you're on, and the mask is where you're looking to see if you're trying to find collisions with that. Okay. Now I'm going to check real quick to see how far we are into this video. Looks like we're about 20 minutes in, so I'm going to end it here. And we've got our basic enemy that is walking back and forth. I'm pretty happy with how this turned out. Although, you know, I always do this, don't I? Every single time I'm like, we're going to finish it up here, and then I have another idea. But for our walking enemy, we do want to have the sprite turn around as well. Currently, the sprite isn't turning around. So for flip H, set it to true, so it's facing this way. What the heck? Our sprite must not be centered quite right. Is there an offset on it? Let's see. Yeah, that's a little bit annoying. It's like not quite centered. Ooh, that irks me. That is just a little bit annoying. Okay, well, it's gonna have to be fine. I'll survive. So turn flip H on, and then come into here, and we're gonna get access to our sprite. So on ready, var sprite equals animated sprite. And then inside of here, we're just gonna set flip H. So we'll say flip. Actually, this comes from somebody who was commenting about how to do this easier with flip H. So we're gonna do that inside of our enemy. Flip sprite dot flip H is equal to direction is greater than 1. No, 0. Direction is greater than 0. So what this means is our flip H will be set to true if our direction is 1, and then our flip H will be set to false if our direction is negative 1. So that should work for our little character. Invalid operands vector. Oh, we gotta do direction.x. I just did direction. So what's happening is it's saying you're trying to compare a vector to and an int, and you can't compare those two things with the greater than operator. And that's because we want to do direction.x anyways. We don't care about the y value. So that's how we got that error. Now you can see our little guy turns around. Let's turn off visible collision shapes. And now our little cute enemy turns around nicely. And we can take this code, the exact same code, and we can apply it to our player character as well. So instead of doing this right here, we can just say animated sprite dot flip H equals input.x is greater than 0. And I don't remember exactly the name of the person who commented this. I hearted the comment, and it was back when we were first setting up our players' animations back in that video. So yeah, I appreciate the comment, and it was a great idea, and now we can apply it to both our character and the little enemy here in our game. And we're looking good. This is looking much better. I'm happy with how this episode went, although I will say that it took me 3 tries to get this episode the way that I wanted it. Hopefully future episodes aren't quite so hard. But this is looking great. Hope you guys are having a lot of fun. In the next episode, we're going to address our hurtbox and hitbox scenario so that we can apply the same damage that we receive from the spikes to our little enemy here as well, and create a system for doing that so that we don't have to redo it every single time we create a new enemy. We can just easily apply a hitbox to an enemy, and then it will just automatically work. So that's what we're going to be doing in the next video. Hope you all enjoyed this one. Thank you all so much for watching it, and I will see you all later.